Welcome back, everyone. So, as you know, the title of this chapter is Measurements and Problem Solving. So, the first part of this chapter, we've been talking about measurements, how we can explain a measurement in terms of accuracy and precision, that the more significant figures a measurement has, the more precise that it is. And in the past 2 or 3 videos, we've been talking about how to determine if a number is significant or not, and what the rules for significant figures are in measurements, and when doing mathematical operations with those measurements. In this video and in the rest of chapter 2, we're going to focus on the unit that is associated with a measurement. And units are really important, as I mentioned, I believe, in the first video for this chapter, because a unit that's associated with the measurement says something about the scale and the type of measurement that is being made. So as I'm recording this lecture, today is the day that NASA is going to do the first crewed launch since, I believe, 2011. NASA's going to launch 2 SpaceX astronauts into orbit. Kind of exciting. I'm going to watch that later on this afternoon. Certainly hope and pray that it goes well. I hope and pray that it goes well, much better than NASA's orbit or NASA's mission that was in 1999. In 1999 was when the first Mars orbiter was launched to try and get some information about the atmosphere and geography of Mars. Now, since then, our pictures of Mars, we've gotten beautiful pictures from Mars. We've started to learn some more about that planet. It's been really exciting. But the very first mission in 1999 was a disaster, or was not successful. And it was not successful. The orbiter did not bring home any beautiful pictures or useful information about Mars because that orbiter was destroyed in Mars' atmosphere because it got too close to the planet. Why did that first Mars orbiter get too close to the planet and become destroyed and not give us information about the planet? Well, this mission was not successful because it turns out that when scientists were designing the Mars orbiter and when scientists were programming the data to go into the Mars orbiter, there were 2 sets of engineers working on this project, and they did not use the same units. One set of scientists used units that were in the English system. The other set of scientists used units that were in the metric system. And the 2 scientists were not talking to each other, so that the scientists that put the data in the Mars orbiter in one unit, it was expecting another unit, and therefore the mission was not successful. So all of that is to say is that numbers by themselves, while important, but by themselves have little meaning. We need to always report the unit that is associated with that measurement. And scientists knew that already. They knew that already, and early in the 1900s, or maybe late in the 1800s, but early in the 1900s, there was a conference, took place in France, and the scientists decided on a unit system that was based on the metric system. And this system would be called SI for Standard International Units. And it was determined that these are the units that scientists would use when reporting important information to each other when talking about experiments. So these are the first 4 Standard International or SI units that scientists deemed would be the unit used when talking about these quantities. So I've got a little star here. So that star is just a reminder to me, to remind you that there may be a quiz question on this. Obviously, you'll be able to use your PowerPoint notes during quizzes and exams. But these are some important Standard International base units that you should know. And you're probably familiar with these first 3. Temperature is a scale in the Kelvin scale. You may have not heard about that yet. We'll talk about temperature more in chapter 3. But for right now, just know that there is a standard international unit scale. It's based on the metric system. It's called the SI scale, and that is the unit system that scientists use when making measurements. So I got some example SI units here. Probably the one that may be a little unfamiliar to you, aside from maybe Kelvin, is that when you think of volume, you tend to think of gallons or liters or milliliters, but technically the standard international unit for volume is meters cubed. And that's because when you do length times width times height, you get a volume. Okay? So, units, really important when reporting measurements. Scientists' favorite unit system is based on the metric system, and that system is this SI, or Standard International Unit System. Okay, so I know this is a busy slide, a lot of information, but I will try to break it down to you into the parts that are going to be most helpful to you. So we said that when writing measurements or writing numbers, their numbers can be really, really, really big or really, really, really small. One way to write numbers that are really big or really small is using scientific notation. Another way we can write numbers that are really big or really small is to make use of these SI, Standard International Prefix multipliers. And what these prefix multipliers do is they change the value of the unit by a certain power of 10. So this table that I have here is a table that's from the Trode textbook. So let's just kind of take this apart a little bit and get the information that we need to. So this table lists the appropriate prefix, symbol, and power of 10 associated for each multiplier. So I think the most important parts of this chart are the actual prefix, symbol, and the power of 10. Okay? And the way that this table works is that this table is set up so that you put this power of 10 on the unit that's in common, and it's in terms of 1 of whatever the prefix is. So, for example, 1 millijoule, J is joule, you'll learn about that in chapter 3, but if I wanted to know how many joules were in 1 millijoule, here's milli right here. So 1 millijoule is going, I'm going to travel over here, is going to be 10 to the negative 3, or 1 times 10 to the negative 3 joules. Why 10 to the negative 3? Because 10 to the negative 3 is associated with milli. So 1 millijoule is 1 times 10 to the negative 3 joules. If I asked for 1 milligram, that would be equal to 10 to the negative 3, or 1 times 10 to the negative 3, but 10 to the negative 3 grams. Grams is the unit in common between those two. Power of 10 goes on the unit that's in common, which is grams, and it's always in terms of 1 of the prefix. So 1 milligram would be 10 to the negative 3 grams. 1 microgram, and micro is that U with the funny little tail on it. 1 microgram would be 10 to the negative 6 grams. Again, that power of 10 going on the base unit. And so on and so forth. So that is how this chart is set up. This chart is set up so that with 1 of whatever prefix you have is 10 to the whatever that prefix is, but that power of 10 goes on the base unit. the unit that's in common. That's what I have tried to illustrate with these first 3 conversion factors that I'm underlining right now. The ones that are underneath the conversion factors I have underlined, that would be in terms of one of the base unit. Okay? So I tend to use this table the way that it's written. So I tend to use it in terms of one of the prefix, because that just means I put the power of 10 on the unit that's in common. I have starred the prefixes and the powers of 10 that are the most common in this course. Now, obviously, you'll be able to use this chat or this slide for quizzes and exams, but the ones that I have starred are the ones that are going to be the most common used in this course. Okay? So basically what I just said, I think, is summarized on this slide to remind you that this power of 10, it's determined by the prefix, but it goes on the base unit. And most of these I'm sure that you've heard of already. You've already heard of centi, you've heard of milli. You may not have heard of micro before. And micro, that tends to be the prefix that students get a little confused with because of all these M's. The way I like to remember micro, aside from this U with the funny little tail on it, is this cartoon. I don't know if you've taken Greek at all. Maybe some of you have taken Greek or Latin for your medical terminology class. But the way that you say this little symbol in Greek is mu. So cows in Greece say moo moo. So just remember that micro, the symbol for micro is not M, that's milli. And it's not capital M, that's mega. But the symbol for micro, which is 10 to the negative 6, is mu, the U with the funny little tail on it. So there's mega, milli, micro, milli, kilo, and insta. Okay? So those powers of 10 on the SI prefixes are going to be really important to use when expressing measurements and when doing calculations with measurements. And we're going to be doing calculations with measurements and the units in the next video.